This is February, March 2022. Variant 42 question. Number 3. A small wooden block of mass M floats in water, as shown in figure 3.1. This is the diagram 3.1. The top face of the block is horizontal and has area A. The density of the water is rho. State the names of two forces acting on the block when it is stationary. The two forces acting on the block are upthrust and the weight. The upthrust is the same as the weight of the water displaced by the wooden block. And the weight of the wooden block is equal to the mass of wooden block times the g, which is your acceleration due to gravity. Since the block is stationary, it means that your resultant force U1 is minus your weight is equal to 0. There's no resultant force acting on the wooden block since the block is stationary. Part B, the block is now displaced downward as shown in figure 3.2, so that the surface of the water is high up the block. When the block is displaced downward, the volume of the water displaced by the wooden block increases. This means that the weight of the water displaced by the wooden block also increases. Therefore, the upthrust increases to a value called U2. So the upthrust increases to U2 in figure 3.2 compared to U1 in figure 3.1. Your weight remains the same. Therefore, your upthrust is larger than the weight. There is a resultant force acting upward. Then the question says, state and explain the direction of the resultant force acting on the wooden block in this position. The upthrust is now greater than the weight of the block. There is a resultant force acting upward. This is the answer for the question. Part C, the block in B is now released so that it oscillates vertically. The resultant force acting on the block is given by F equals to minus A rho Gx, where G is the gravitational field strength and X is the vertical displacement of the block from the equilibrium position. In part 1, explain why the oscillations of the block are simple harmonic. For simple harmonic motion, your F must be proportional to X. This is correct because your A, rho and G are constant. Therefore, your F is proportional to X. The negative sign in the formula F equals to minus A G rho X. The minus sign shows that F and X are in opposite directions. So this is how it's scored the 2 marks. Then in part 2, show that the angular frequency omega of the oscillation is given by this formula here. To do this question, we need to understand that for simple harmonic motion, the acceleration is proportional to X. The minus sign here shows that your A and your X are acting in opposite directions, and omega squared is a constant. The second thing you need to know is Newton's second law, which states that F equals to ma. So therefore, your A equals to F over minus m. Substituting F as minus A rho Gx into this formula will give you A equals to A rho Gx divided by m. A, rho, G, and m are constants, and it is equal to the omega squared. Therefore, omega squared equals to A rho G divided by m. So from here, your omega equals to square root of A rho G divided by m. And these are the things you need to understand about simple harmonic motion in order to do this question. In part D, the block is now placed in a liquid with greater density. The block is displaced and released so that it oscillates vertically. The variation with displacement X of the acceleration A of the block is measured for the first half of the oscillation, as shown in figure 3.3. You notice the graph in figure 3.3 consists of a straight line with the negative gradient passing through the origin, which is represented by the green point here. There is a relationship between the acceleration displacement graph and the displacement time graph. The motion of the block from A to B is represented by this part of the graph in the displacement time graph. You notice that the amplitude at A is 0.02 meter and the amplitude at your B is 0.016 meter. The larger the amplitude, the larger the energy of the vibrating system. Since your XB is since XB is smaller than XA, the amplitude for this position B is less than the amplitude in position A. Energy is lost during the oscillation. There is damping. So the motion from A to B is represented by this graph here. Part 1. Explain why the maximum negative displacement of the block is not equal to its maximum positive displacement. The maximum negative displacement of the block is minus 0.02 meter, and the maximum positive displacement of the block is positive 0.016 meter. The difference in the amplitude is because of damping due to some viscous forces. Then in part 2, the mass of the block is 0.57 kilogram. We have to calculate the decrease in energy of the oscillation for the first half of the oscillation. To do this question, we need to know that the total energy, which is represented by ET, is equals to the sum of the potential energy plus the kinetic energy. Or you can say that the total energy of the system is equals to the maximum kinetic energy or the maximum potential energy. I will use kinetic energy because we know the maximum kinetic energy is half m omega squared xo squared, where xo is the amplitude of the vibration. The decrease in the amplitude of the vibration shows the energy is lost. Omega squared is the gradient of the line that is represented in figure 3.3. So the loss in energy will be equal to half m omega squared. XA is the amplitude at A squared minus XB is amplitude at B squared. So this will give you half times 0.57 times 2.3 divided by 0.02. 2.3 divided by 0.02 is the gradient of this line. Times bracket times 0.02 square minus 0.016 square. This will give you 4.7 times 10 to the power minus 3 joule, which is the energy lost during the first half of the oscillation. This is a summary of the facts that you must know to solve this question. Number 1, you must understand that upthrust acting on an object in a liquid or in a fluid is due to the difference in hydrostatic pressure P, where P is equal to H rho G, where H is the height, rho is the density of the liquid or the fluid, and G is the acceleration due to gravity or the gravitational field strength. Number 2, upthrust U is equal to the weight of the fluid displaced by the object. Therefore, your upthrust is equal to the volume of the fluid displaced by the object times your rho times your G. Your number 1 and number 2 is found in the AS, the syllabus of this physics syllabus. Number 3, simple harmonic motion occurs when the resultant force F or acceleration A is directly proportional to the displacement X from the fixed point. And F and X or A and X are in opposite directions. You notice when the block is first pushed downward, your X is measured in the downward direction. But then the resultant force is acting in the upward direction. It shows that your resultant force and your X are acting in opposite direction. Number 4, in other words, F is directly proportional to X or A directly proportional to X for simple harmonic motion. and A is equals to minus omega square x. Number 5, understand that damping is caused by some resistive force in the oscillating system. And finally, the formula for maximum kinetic energy for an object performing simple harmonic motion is equals to half m omega squared xo squared.